The next one, what does it factor into?
X minus 1, X plus 3.
X, yep, minus 1 and X plus 3. Doesn't matter what order they're in. And I should have written out here in front the limit as X approaches negative 3. So now these two will cancel, right? So the limit as X approaches negative 3 of X plus 1 over X minus 1. Now we can do direct substitution. I can plug in negative 3 and get negative 2 over negative 4, which is 1/2, which is what we got from the graph. So you don't have to come up with this graph. Yes, sir.
I can plug in 1 because it's going
Yes,
infinity.
that's next.
Okay.
Yep, that's on the back. Oh, yeah. Good question. Okay. So, we know that, no, we didn't call it a non-removable infinite discontinuity. That is an asymptote. That's all that means. That's graphically a vertical asymptote. So if a rational function has a vertical asymptote, okay, and since the y values do not approach one specific value from both sides at a, again, that's vertical asymptote, then the limit does not exist. However, we can determine if the one-sided limits approach negative infinity or infinity. In order to do this, we will basically have to do a graph or a table of information. So what I mean by that is we know that here, just like on the last problem, when we plug in 1 and we have of X plus 1 over X minus 1, when we plug in 1, I get an undefined answer, right? I get something divided by 0. So what we need to do is not plug in 1. And here is where a calculator would be very necessary on filling out tables. So like I'm going to pick a value that's slightly to the left of 1. And that, in this table, they've put 0.9. So if I do 0.9 plus 1 over 0.9 minus 1, somebody tell me what you get. Negative 19, right? Let's do 0.99. So if I do 0.99 plus 1, and then I divide that by 0.99 minus 1, what do you get there? Negative 199. So what is it approaching?
0,
Negative infinity. Because the first one was negative 19. The next one was negative 199. If I did 0.999, it would be even bigger. So it's getting, well, smaller, I guess. Negative infinity, a negative huge number. So here's what's going on. We're dividing by 0. So here's now where you really don't need your calculator. I just wanted you to do that just to figure it out. When we are taking a number and we're dividing it by 0, not 0 divided by 0, but a number divided by 0, then it's going to be infinity. So when you divide by 0, it's not that, well, it is undefined. It does not exist, but it's going towards infinity. Now we just got to figure out, is it going up to infinity or down to infinity? So all we have to do here is figure out signs. We don't actually have to do this problem. I know that when I plug in, what was it, 1, this gives me, in this case, it gives me 2 over 0. So I know it's going to be infinity. I just don't know if it's positive or negative. So 0.9 plus 1 is a positive number. I don't care what that number is. I just care that it's positive. And then 0.9 minus 1 is what? Negative. A positive divided by a negative is a negative. That's why my answer is negative infinity. So we can divide by 0 now. It's infinity. You just got to figure out if it's positive or negative.
Are we really dividing by 0?
No. No, we're not really, because it's a limit. We're saying what is it approaching, and it really doesn't exist because you can't approach infinity. But we're getting an idea of what it looks like.
We're getting this close to it.
That's right. We're learning information about the graph, which is the purpose. Okay, so this one, same thing. Limit as x approaches 1 from the right. It doesn't matter if it's left or right when you plug it in. It's still 2 over 0. So again, I know it's going to be some kind of infinity. I just got to figure out, hey, is that positive or negative? So this time, we're picking a point slightly to the right because it has a little plus sign. So 1.1. So on top, positive or negative?
Positive.
On bottom, positive or negative?
Positive.
Positive. So your answer is positive infinity. And notice that was the same answers we got on the other page. Look at y'all. Ooh, so smart. So smart. You just divided by 0. Go home. Tell all your friends. They'll be amazed. Okay, maybe not. Alrighty then. The next one. Notice this is a square root function. We've been doing this in pre-cal. Actually, it's funny. They go hand in hand right now. And we've been graphing those, so the graph is already there for us. So we are going to do this limit. Now, I can look at this graph, well, maybe not, and kind of guesstimate the answer based on the graph. But let's do direct substitution, like we've learned how to do, right? We take in that 3 and we plug it in. So it becomes, well, I'm just going to plug it in first. Square root of 3 plus 1 minus 2 over 3 minus 3. Uh-oh. What does it give us? 0 over 0, which is called the indeterminate form.